Welcome to the Cambridge Tech Podcast, talking all things technology from the heart of the UK's tech capital. Here are your hosts, Faye Holland and James Parton.
Hi, I'm James.
And I'm Faye.
So how's your week been, Faye?
Not bad, thank you very much. I had the delight of going to the Forefront new office opening event, which was brilliant. So Forefront, I mean, we've covered them in the news before. They're innovative tunable duplexer technology, and they simplify mobile radio front-end design for smartphones, wearables, and other IoT devices. So incidentally, we've got founder Leo Lachlan and commercial director Alexander Dausch joining us later in the year, so they can tell us as much more about the technology. But you know what? It was one of those events that was just flipping lovely. I mean, it really was. Ronald Whiting was there. What he said about the team and the office move and their growth and the investors was just, it was so genuine and just so lovely. And what I liked even more was the team took you on the tour of the office, all the main development parts of the technology. You went round in like a little tour and they gave you a sample of the things that they were doing. And it was great because you actually got to see the technology in practice by the people that are creating it. So it was just a really positive event for them. And I think that, they were really proud as well, which was great. I got super excited about something. I got to wear, when you go into like new offices and you have to put the covers on your shoes, in their test lab, you have to put on these electrostatic discharge shoe covers, which were a first for me. And then you have like this long bit that goes out of the back and everyone's like, well, what do you do with this? And you have to put the contact on your skin because it's to stop the static. So I was like all over excited about wearing shoe covers. So I'm sure they weren't very impressed with that bit, but the rest of it was awesome as well. So really, really good job by Sue Hunt and the team over there.
So your hair wasn't standing on end then as you were walking around?
No, but you know what? I'm really bad. So you walk into the lab and there's like this mat that you go on, which obviously is grounding you, and I really wanted to step on it and yelp, and I'm like, okay, maybe I better not do that. Terrible sense of humour as well, so that was kind of my real highlight of the week. And this week's already started. It's big event time at the moment. So we've got London Tech Week on at the moment, and I know there's loads of people from Cambridge down there, from Beyond Math and other places. And here in Cambridge, it's Cambridge Wide Open Week. So that started yesterday. There's loads of pitching events going on, and tomorrow is the iconic Cambridge Wide Open Day. So if you haven't got your tickets for that, then there might still be just about time to get involved. Otherwise, just go follow on social and see what you've missed. And then what else? The last thing that I thought we could share is Business Weekly have just started their celebrations for the 35th year, which is just incredible, isn't it? And there's this whole feature in the paper about the highs and lows of the 35th years, written in TQ's inimitable style. So, I mean, they've been great supporters of the podcast. So I guess we both send them our celebrations and congratulations on this milestone achievement.
Yeah, we certainly do. Yeah, happy birthday.
Yeah. Anyway, so that's me. What about you? Did you manage to get to South by Southwest?
Actually, I didn't. No. It was a kind of combination of stuff going on in Cambridge, and I don't know, honestly, I went through the roster of who was speaking, and there just wasn't enough to get me down there, if I'm honest. So, not this year, although I did spend a fortune on a ticket and not use it, so there you go.
Oh, that's really bad. I mean, I was quite surprised at how many of our startups were down there. There seemed to be quite a big exhibition zone. I know Cambridge Surgical Models were down there, so there did seem to be a little bit of traction on it. Maybe it's a follow-up, see what people thought about it, and maybe better luck next year then.
Yeah, maybe. But it was another good week, despite the weather. Where did the sun go? It's wet every day, isn't it? It's horrible. But I visited our lovely Officers' Mess site at Duxford. If you haven't been there and you're into World War II history, you really must go, because it's a listed building and it's packed full of history, including like where pilots have written their names in the lavatories and stuff like that. It's amazing, and it's all still there. We hosted another visit from the Model Centre, which was great. Attended a session put together by Jane and the Science Park team on their plans and vision for sustainability sustainability on the Science Park, which was really good. Caught up with the lovely Caroline Hyde from Cambridge Enterprise. Cambridge Wireless brought over a delegation of US cybersecurity startups who were keen to learn about the Cambridge cluster and network. So, another busy week.
Yeah, no, great. And do you know what I'm finding very interesting at the moment? The volume of really valuable international delegations visiting Cambridge. There seems to be this, big uptick of interest and desire for collaboration, which is absolutely brilliant. So let's move on to the news. I'll start with Cambridge chip architect Arm, who's driving AI-inspired revolution in car manufacturing after launching a novel bleeding-edge technology, Xena Compute Subsystems. Dipti Vakhana, Senior Vice President and GM of the automotive line of business for Arm, says the rollout solves one of the toughest challenges facing car makers, bringing innovation to drivers faster. She says that traditional silicon development times often delay vehicle rollouts, but that all changes with Arm's Xena Compute Subsystems. She says Xena CSS enables automakers to launch new vehicle models at least 1 year faster with a standardized pre-integrated compute platform that dramatically shortens development cycles and enables software teams to start early before silicon even exists.
Fantastic. University of Oxford spin-out NavLife has officially launched after securing $4 million in combined investment and grant funding. The startup is working to improve how spatial data is captured and deployed across the built environment. The investment features a $3.3 million seed round led by OSE with participation from SOSV, Oxford Capital Partners, Clearance Venture Partners, AE Works, BritBots and Oxford Innovation Finance, alongside a £700,000 grant awarded by Innovate UK last year. NavLife has developed a handheld scanning tool that enables architects, engineers and construction professionals to instantly generate high-precision site scans, using Edge AI and LiDAR into BIM workflows. CEO Chris Davison said, "Our vision is to make built environment 3D data more immediate and accessible to those who need it throughout the life cycle of a building. We improve profit margins for our users and make buildings more environmentally sustainable. While we're still at the beginning of this journey, this milestone puts us in a strong position and we're just getting started."
Bravo to NavLife. And actually, I think it's important just to say this is a University of Oxford spin out, but we are covering much more news at the moment. And certainly after we did the session with Andy Williams on the Oxcam supercluster, there's definite appetite for us to be covering a little bit broader news. So that just explains why we're adding some of these other things in as well. But let's go back to Cambridge for the last piece of news with Remedium, a Cambridge University clean energy spin out developing an ultra-low-cost carbon capture system for heavy industry, who have won a £50,000 Climate Impact Prize at the Net Zero Technology Centre's annual TechX Demo Day in Aberdeen. Remedium's technology, Lime Loop, captures carbon dioxide from industrial processes such as cement and steel production, sectors that are especially difficult to decarbonise. The system uses a custom-made synthetic limestone and a heat battery to trap more carbon dioxide at a significantly lower cost. It promises to remove over 90% of emissions while producing high temperature heat for industry, with the potential to reduce capture costs by more than 80% compared to current methods. So well done to the team there.
Yeah, that's great. Well, that's the end of this week's news. So for today's episode, we talked to Teja Potočnik, founder of Nanomation, about her journey as a founder and how nanomaterials have the potential to transform chip production.
Hi Teja, welcome to Cambridge Tech Podcast. It's great to have you with us today.
Thank you very much for having me.
And we know each other for a couple of reasons. First of all, the Founders Programme, you were in that first cohort, and you were also a winner of 21 to Watch this year as well, which is great. But for everyone who doesn't know you, would you like to introduce yourself and just tell us a little bit about your journey before we get onto the conversation about Nanomation?
Yeah, of course. Thank you again for having me. My name is Teja Potočnik. I'm originally from Slovenia, where I initially went to do international baccalaureate program, where I basically studied everything in English because I was set on studying abroad. And so then I went to do my bachelor's degree in material science and engineering. And I chose that degree because I was always interested in physics and chemistry, and that was kind of a combination of both. And during that time, I kind of fell in love with nanomaterials and nanotechnology in general. So then PhD was then in nanomaterials, and specifically nanomaterials electronics here in Cambridge. I finished my PhD about a year ago, and during my PhD, I also founded a company, Nanomation, where I'm now a CEO.
And so both of those, so it's great to have the person with the PhD on nanomaterials, so you can tell us all about that. And obviously we're going to come on and talk about Nanomation as well.
Yeah, we are. Before we do that, though, you've got a pretty impressive list of achievements already in a short career. I've got a few here. So you won the Female Founders category at the Wolfson Entrepreneurship Competition, and that led to you presenting your research at UK Parliament, I believe. Is that right?
Yes. Yeah, the Wolfson Entrepreneurship Competition was really sort of a pitching competition at Wolfson College, where we presented what we do, and then it was a series of sort of judges and panels. And we won the award in the Female Founders category, which I think was really, really great and sort of good recognition for what we were doing. And they had a great network of people they connected us to. And then the presenting at Parliament, that was STEM for Britain, which was, I believe, a separate competition, but it was presenting what you were doing, your research in the form of a poster. And so it really gave us an opportunity to present what we do to like a very general audience and really talk to decision makers and policy makers in Parliament at that time. I never really thought about it, but it's really sort of important how you get from a stage of sort of groundbreaking research into sort of translating that. And I think there's like this gap that needs to be addressed. And I think initiatives and competitions like that are a great place to do that.
Yeah, and Faye obviously already touched on the fact that you've been a winner on 21 to Watch. You've obviously been successfully selected to be in the Founders Programme. You're actually actively competing in another competition right now, I believe, which is Tomorrow's Shapers, which is organised by the European Patent Office. Tell us a little bit more about that.
Yeah, so this is a very interesting competition that I didn't actually know about. I was just informed that I was selected, which was great. So they select young people under 30 who are basically inventors. And so they're inventions that contribute to the United Nations Sustainable Development Goals. So anything that addresses sustainability, healthcare, social challenges and things like that, and sort of digital transition as well, which is where we come in. And so 10 Tomorrow Shapers, so I'm one of them, were selected out of over 450 candidates. Again, sort of a lot of international recognition, a great network of people. And as part of that, out of 10 of us finalists, there will be additional sort of winners selected via public vote. So yeah, you can vote for me at the European Office website.
Yeah, we'll put the link to that in the show notes. But I mean, we talked to a number of academics spinning their research out of the university or developing companies off the back of their research. Sometimes it's not immediately obvious of the benefits of entering competitions and putting yourself forward. But, you know, you touched on things there like, you know, the network of people that you're introduced to. So I'm assuming that you've had a very positive experience from going through these kinds of programs.
Yeah, definitely. I've been through a lot of programs. So initially, I have to say, we sort of started while still doing my PhD, actually, with the help of Cambridge Enterprise, who've been really, really supportive. And actually, I think it's important that there's a sort of support for young researchers and PhD students, especially because you don't really know anything about it at the time and you don't really understand the importance of intellectual property either. So I remember when we first invented this technology that we have, and it took us we had to wait a very long time to publish a paper because we were sort of given advice not to publish anything because otherwise you can't patent it. And it's just things like that you're not necessarily familiar with unless you sort of know people. Yeah, and then still during my PhD, I also did something called Conception X program, which is a program in London that allows you to do all of this training, entrepreneurship training, but alongside your PhD. So it's part-time. And that was sort of my first introduction into this world and learning about how to run a company and sort of leadership and finances and all of those things that you don't think about. And then after that, I also did the Founders program, which was full-time here in Cambridge. So all of those things kind of collectively helped me get there.
So you've certainly had a busy few years, and I think you've just highlighted that importance of, your subject matter expert, but you also wanted to learn the other skills that were going to be required of starting a business. But let's talk a little bit about nanomaterials first of all. One should never assume that everyone knows what we're talking about. So could you just tell us, what are nanomaterials? What are they used for? Just give us a quick overview, please.
Yeah, of course. So nanomaterials are materials that are at the nanoscale. So that means 1,000 times smaller than the width of a human hair, so 1/1000th of a meter. And they include materials like semiconducting nanowires or carbon nanotubes, 2D materials like transition metal decalcogenides and graphene, quantum dots, and so on. So there's a wide range of materials. They can be used for various different things. So particularly in electronics, they can be used for things like transistors, photodetectors, photodiodes, and things like that. So they have a lot of interesting properties because of their small sizes, but also interesting geometries, like, for example, nanowires and nanotubes. So there's a lot of potential and a lot of research on these materials because of their unique properties.
So this potential is what will enable the semiconductor industry to start manufacturing using nanomaterials for the first time, and that's where your solution actually comes in. So can you just talk us through a little bit more as to why chip manufacturers need to change their process? I mean, there's got to be a limit to how much you can put on the chip, which is where nanomaterials come in. So can you just explain that a little bit for us as well?
Yeah, of course. So I assume most people have heard of Moore's law, which states that the number of transistors on chips doubles every couple of years. So that means that we're making transistors smaller and smaller and sort of densely packing them on chips. And this is now becoming progressively difficult because we're reaching that limit of how densely packed they can be. So a lot of the research on sort of semiconductor technology is on new materials. And amongst those, nanomaterials offer that potential solution where they can contribute to improving the performance without necessarily decreasing their size or needing to decrease their size further. But what is most sort of beneficial from nanomaterials is that they can add new functionalities and sort of specialization, where I think really the future of nanomaterials is. So, for example, adding sensing properties and sort of quantum and photonics and all of those things. So it's not just for computation, but sort of adding new functionalities and new types of properties to electronics. Yeah.
I was going to kind of just drill a little bit deeper on those kinds of new use cases. And also like the power side of things as well, power consumption, are there benefits there too?
Yeah, exactly. So power consumption is an interesting one. So a lot of these materials require a lot less energy. So they're a lot more energy efficient, which sort of, means there's energy savings, which is quite an important issue these days with data centers and things like that. So there's variety of different materials depending on the application for what they can be used. But generally, they're a lot less power hungry.
Okay, that's interesting. And you mentioned data centers there. Is that one of the use cases you're looking at right now?
Eventually. I think that's still sort of a longer term application, but yeah.
So one of the things that this brings is when you're working at nanoscale, you get new challenges, whether that's from research or it's from production. I mean, where are you aiming at? Is it literally across the whole spectrum?
Yeah, so at the moment, our focus is primarily working with semiconducting nanowires for sensing applications. So this is what we're prototyping at the moment. But really, the advantage of what we're doing is translating that cutting edge research, particularly devices that are stuck in prototyping stages because they're so difficult to work with, and translating that into something that can be used commercially. So really, nanomaterials have been studied for decades, and there's so much research out there, so many research papers, but getting that into sort of commercially viable technology and sort of mass production has been incredibly difficult. And this is what we're trying to address. So you have, the most amazing electronic device that's been published in a Nature paper, and we have the technology that allows us to scale that.
And I guess building on that then, when you look at the whole production line of from start to finish, are you focusing more on the kind of the software and the design side of things and kind of going more from like a fabless approach, or have you not yet decided, how far down the stack you're going to go?
Yeah, so we're a fabless company. We have a sort of software and hardware platform together, but primarily we use nanoscale optimized markers, which allow us to analyze materials much more efficiently from microscopic images. So the core of our technology is the software and computer vision that comes from image analysis.
Okay. So that, the technology and the potential for the technology sounds super disruptive. Give us a flavour of the market opportunity. What kind of market size are we talking here, and what percentage of that market do you think is addressable from your technology?
Yeah, good question. So sort of what we're focusing at the moment is semiconducting nanowires, particularly for sensing applications, specifically in the infrared spectrum. So that's something where nanomaterials like semiconducting nanowires have a lot of advantages in. So we're able to significantly lower the cost of the sensors, whilst also enabling sort of new functionalities like a broader wavelength detection range and things like that. So yeah, I mean, obviously sensing is a huge market, and potentially we're then able to address other parts of sensors as well. So like in the UV or X-ray range.
And that's kind of an interesting question and answer, because as an early stage company, how do you choose which areas to focus on? And, you're choosing them because you think that's got the larger propensity of actually succeeding, but it may not. So how do you go through that process?
Yeah, we spent a lot of time researching this, and actually we've chosen the one that's got something that we know very well. So, we have experience in doing, but also has a potential to have a very quick route to market, because a lot of the things that, we can address, which is, next generation computing and things like that, is a very long way away. And so for us, the priority really was to get some commercial validation. So this is where, we're targeting applications that allow us to get there faster. But ultimately, we're currently prototyping, and it's really to demonstrate the value of our methodology and technology in general. But we want to be a platform company, which allows us to basically address any material and any application. It's just we have to start somewhere. So yeah.
Of course. And are you already talking to industry, or is it you are? Okay.
Yeah, we are. We're getting really good feedback around sort of our prototypes, and sort of the next stage really is to progress these conversations.
Yeah, that's a good segue, I think, into the next question. Just getting a sense of the company itself, the size of the company, where you are in terms of stage. Are you looking to kind of fundraise? Give us a run through of like the company itself.
Yeah, so at the moment we're a company of 6 people. So we were originally 4 co-founders, but we've brought 2 new people to the team. We're currently focused on technical development, so we're spending a lot of time in the clean rooms making prototypes. But kind of in the next stage, we really want to focus on commercial validation. So we want to get to a stage where we have joint development agreement or sort of partnerships with the industry. So that's really something we're working towards in the next year. Yeah.
And do you think achieving those validation milestones will then unlock the next round of funding? Is that kind of how you see things?
Yeah. So we're fundraising at the moment. So we're hoping to close that very soon. We've recently manufactured our first prototypes about 2 months ago, which has been a major milestone for us, and sort of really great to see, not just from sort of, just general progress, but just from like technical validation.
And you talked about commercial validation and getting partners on board. What sort of companies are you looking for, just in case there's anyone listening that can point you in the right direction?
Yeah, no, we're always sort of interested to talk to any sort of semiconductor manufacturing vendors, so foundries, but then also sensor companies, very broadly speaking. Yeah.
And how's the Cambridge ecosystem been for you? Because we've got lots of fabulous semiconductor companies in Cambridge. Do you all talk to each other? Do you help each other out? How's that working?
Yeah, no, it's been great. I know a lot of semiconductor companies in Cambridge, and I think we're very early stage. We have a lot of sort of validation and sort of proof points to get there. But yeah, we know a lot of people. We've spoken to a lot of people in Cambridge. It's really great to be connected to many of them. Yeah.
Building on that question from Faye, in terms of the collaboration with other companies, you've been on the Wolfson program, you've been on the Founders program. What's been the support like from the kind of broader Cambridge ecosystem, not only within the university, but outside the university? What's it been like building a company in Cambridge and getting that support to commercialize your research?
Yeah, I think we're very lucky here. It's not just introduction to like training programs and accelerators and things like that, which I think Cambridge has a lot of, and they're all like extremely good quality. But it's also just knowing people who've worked at certain companies, who work there sort of within the industry, but then also general business related, and anything from like policy, regulation, law, things like that. Everyone knows everyone, and it's great. And so, every time you go to a new event, you meet people that you already know, which is great. But then, you find out there's additional connections and things like that you weren't aware of, which is great. Yeah.
Is there anything on your journey so far that kind of has caught you off guard, you were surprised about, or anything that someone has raised with you? Like, for example, you made a comment earlier on as when's the right time to place a patent? You don't want to go too early and let the cat out of the bag, because as soon as it's out, it's out.
Yeah.
Are there things like that you could give as advice for other early stage founders?
One of the things, we started with a very different vision of what we wanted to do. And I suppose one of the things that surprised me is sort of how quickly that changes. I suppose, like, you speak to people in the industry and you get feedback, and you speak to mentors and you get feedback, and sort of what you can refine what you're talking about and get the idea out there, which is a lot clearer. And sometimes that seems like, you're changing your narrative too much, but actually you're just sort of refining it. And I think that's really important, to be able to adapt to sort of the new information that you get all the time.
No, I mean, I think it's really interesting. Thank you for sharing that. I mean, you've got a busy year ahead of you. I mean, certainly it might even be months, mightn't it? If you're just about to close your funding round, you've got to get the pilots, proof of concepts underway, and the commercial relationships. Is there anything else that you're looking to achieve in the next, say, 12 to 18 months?
No, I think, really focusing on prototyping at the moment, and our technical development is the priority, so we can then advance our conversations with customers, which is really what we're aiming for in the next year. Yeah.
And you're raising your pre-seed, is that right?
Yeah, that's right.
Are you working with local angel groups? What kind of reaction are you getting from the investor community?
Yeah, no, it's been really good. We're speaking to VCs and angels, investors, some corporate investors, actually. So, a mix. And I mean, it's been a bit challenging at times, but I like talking about what I do. So we'll see. We're hoping to close soon. So.
That's great. It's been really interesting having you on. Thank you very much, Teja. You are very early stage, and it's good to have that mix of different sizes of companies. So thanks for coming on, and definitely come back and tell us some more when you've got some updates.
Yeah, I will. Thank you very much.
Thank you.
Today's show was produced by Carl Homer of Cambridge TV and supported by our media partner, Business Weekly. The Cambridge Tech Podcast is available on all major podcast platforms and on cambridgetechpodcast.com. If you've enjoyed this podcast, please give it a 5-star review. It'll really help others discover the show.